Tonight we're going to do the linear epsilon delta proofs. Suppose, for some reason, namely me, you want to prove that the limit of a linear function 2x plus 1 is equal to 7 as x approaches 3. Obviously, it equals 7 by substitution. You begin by calling attention to the epsilon delta definition that we proved earlier. What is the definition? The limit of f of x as x approaches c is L. We have an f of x. Our c is 3. Our L is 7. If for each epsilon greater than 0, epsilon is the radius of the range, then there is a delta greater than 0, which is the radius of the domain, such that if 0 is less than absolute value of x minus c is less than delta, deleted neighborhood on the domain, then the absolute value of f of x minus L is less than epsilon. Now, these were the facts about the definition. What we have to understand is that I'm going to teach you how to do a backwards proof. If you remember just a corollary that we use every day, we can look at a map and trace our path, for example, from Houston to Austin. By the same token, we could also route the same path from Austin to Houston. Well, if you think about it, that means we could start with the then, what we're trying to prove, arrive at the given, and if that is true, we've done our proof. So, look at the structure of the proof. You have this such if right here. This is the if statement of the proof. That is the then. So, I'm going to start with the then. I have to prove that I can get from the then to the if, and if so, I should be able to go the other way around. So my f of x is 2x plus 1, minus my L, which is 7, is less than epsilon. Now, from the definition that we worked through, the limit of f of x as x approaches c is L, epsilon was the radius of the range and very enticingly small. This will reduce down and simplify to this. Then by a theorem we may or may not have proved when we were taking our Algebra 2 class, we can factor this 2 out of the absolute value by a theorem that we could prove that the absolute value of the product is the product of the absolute values. From here, you get this by simplification. Well, if you study this hard, this was after the then, so in a conditional statement, this is a proof. We got to something that looked like x minus c less than delta. So what this tells you is that delta has a relationship to epsilon by 1/2 of epsilon. Now, epsilon and delta are radiuses of the range and domain respectively, and of all the drawings I did yesterday, we understand that they're positive numbers. So, what I'm going to do is reverse my direction. So, I am going to say like I am brilliant and I just thought of this, let delta equals epsilon over 2. Like this is just something that came out of my hat, and I am letting delta equal epsilon over 2. Also coming out of my hat is that we know epsilon is positive, 2 is positive, therefore epsilon over 2 is positive. So since the world is positive, we can make a statement that 0 would be less than any x minus your c is 3, less than epsilon over 2, starting from this last statement. By product of multiplication, you would have 0 less than twice absolute value of x minus 3 less than epsilon. Notice, spiritually, I'm retracing these steps. I'm going to drop my 0 because the world is positive. So 2 is less than the absolute value of x minus 3 less than epsilon. So put the 2 in, because 2 is positive, so we're throwing it in. So the absolute value of 2x minus 6 is less than epsilon. Notice I'm right at this step. Another way to write a negative 6 is 2x plus 1 minus 7. Eureka! I have gotten this of the form the absolute value of f of x minus L less than epsilon. So what I say, and I'll change the color of the pens just to highlight this for you, so you won't get too confused about all the action that's going on here. Let's see. Let's choose I haven't chosen a hot pink around here, so let's just choose another purple. I'm going to add a little statement to this, and I can say this is of the form the absolute value of f of x minus L less than epsilon, meaning I got to my then statement. Therefore, if delta is half of the radius of the range, if it's half of it, then if that is so, then the limit as x approaches 3 of 2x plus 1 will equal 7 for epsilon greater than 0. Pretty cool, huh? Now, what a graph is going to look like with this, and I hate changing the pages, but I really don't have any room. So I'm going to change the papers, and what you have here, remember, it was a limit of 2x plus 1 as x approaches 3 is 7. Let's correlate it to the epsilon delta definitions graph. You have here x equal 3 on the x-axis. You have here a delta radius, and that is, as you know, epsilon over 2. So this is 3 plus epsilon over 2 and 3 minus epsilon over 2. This would have, and in the definition I proved that 3 was deleted, so I'm not going into that explanation again. And here's my L at 7. And this would be 7 plus epsilon. This would be cell minus epsilon. I'll have horizontal slash lines here. And if you look at the first page, you realize, or look at your definition of limits, all of this was inequalities. Remember, it was 0 less than x minus c is less then delta. It was a less than sign. F of x minus L less than epsilon. That's why everything is slashed. So you have a line with the y-intercept of 1 coming through here. It'll be a straight line coming through here. And at open circle at 3, 7. And it's going to go on out. If we color this, and back to the pen settings, that would mean that we had a region between 3 minus epsilon over 2, because that's what delta is, epsilon over 2. And with another pen setting, changing that up a bit, we have another color. Let's go to a light blue. And we have L equals 7. Now, do you see how that 7 signifies that the limit equals L? You see C is deleted at 3. Why? Because it's 0 less than the absolute value of x minus 3. Boy, that was a bad choice of colors. I better change that again. It surely doesn't do a good job to when I'm writing. I'm learning, gang. I'm learning. Don't choose that color, Josie. So we'd have 0 less than the absolute value of x minus 3 less than delta. Okay, where delta is epsilon over 2. So when I go this way, and I have it running this way, this, because of the 0, if you remember the proof on epsilon and delta, this 0 deletes the 3, but f of x minus L is less than epsilon. In that proof, it doesn't delete L, which is 7. That's why we have an open circle. And this is the picture that you would have in your work to show and go aside and put it right beside the proof. So how would the discussion read? It would read, children, by doing an epsilon delta linear proof, prove the limit of 2x plus 1 as x approaches 3 is 7. After you prove that, please draw a graph of your proof. And that's it. So that's linear epsilon delta proofs. The rest will be done in class. Thank you. Nighty-night.